Hello, welcome back. In the last video we spoke about a special instruction in the 8086 called the string instructions. This one we are going to be talking about two different constructions called procedures and macros. I'll help you understand what these are and the differences between a procedure and a macro. So what is a procedure? What can you do with this and how does it work? In high level languages you have something called functions. And a procedure is exactly the same as a function except for one difference. We'll talk about the difference. And the procedure is really something that you would call over and over again within your main program. So you've got a main program flow and you use an instruction called call, C-A-L-L, and the name of the procedure. So call proc A in this example. As soon as the processor sees this, it jumps to the procedure address, it executes the procedure and returns to the main program. It runs the main program again, and if it meets call once more, it again jumps back to procedure, executes the procedure, returns. So what you've really done is by placing this procedure code once somewhere in memory, you have been able to execute it twice in this particular example in your main program. You could have called proc A 100 times in the main program and the procedure would have been still instantiated only once. Why are procedures used? Now it's fairly simple to understand. You really, if a procedure is not used and if you had to use that code 100 times, you would have had to insert that piece of code 100 times within your program, expanding the memory requirements of your program. The procedure helps you to insert it once and to keep calling it whenever you want. And that's not the only reason, right? The procedure also helps you to debug the program only once, because if there is an error, you don't have to debug the error 100 times whenever you have inserted or wherever you have inserted the procedure. All you have to do is debug that one location where the procedure is stored, and if that works, it will work all the 100 times. An additional concept to this is something called the nested procedure. And what's a nested procedure? A procedure within a procedure is called a nested procedure. So in this example, procedure A is called twice in the main program. Every time procedure A is called, procedure A in turn calls procedure B. And procedure B is another piece of program. Now procedure A could call procedure B 5 times. Right? And every time it would go to this one location, execute procedure B and return to procedure A. At the end of procedure A, you come back to the main program again. This is the concept called nested procedures. How does the processor do all of this? How does the processor know when to go there, when to come back, how to come back to this location from where it left, etc. So there are two important instructions to understand. One is the call. Right? So we discussed the CALL, the call instruction. The other one is the RET, return instruction. So how does the processor know what is the next instruction to execute? It is a combination of CS:IP, code segment, instruction pointer, gives the processor the address of the next instruction that it must execute. So if you are able to change CS:IP, the processor automatically jumps to wherever you want it to do. And that's what this call procedure does. As soon as the processor sees call proc, it loads the location of the procedure address into IP. The CS:IP now points to the location of the procedure. And when it comes to the return address, RET, it will come back to the original flow of the program. But how does it come back to the original flow? You can understand that the new instruction pointer gets loaded and the new instruction pointer points to the procedure. But before the new instruction pointer gets loaded, what the processor does, as soon as it sees the call instruction, it pushes the IP onto the stack. Now remember, the IP, the instruction pointer, contains the address of the next instruction. So by pushing it onto the stack, the processor has stored the memory location of the next instruction for use later on. And when is it later on? When the processor sees the RET instruction. The moment the processor sees the RET instruction, it pops the instruction pointer from the stack. This is how this magic is done. So the call instruction is met, the instruction pointer is pushed to stack, the procedure location is loaded onto the instruction pointer, the procedure is executed, the RET instruction is met, the RET instruction pops the IP pointer off the stack, and the processor continues execution from where it left off. And there are two kinds of locations where the procedure could be located. One is what is called the near memory, which is within the same 64 kilobyte of RAM or ROM. In this case, the CS register does not have to change, right? So for example, this is an example of a near call. The main program and the procedure are within the same 64 kilobytes address space. What happens is that as soon as you get this procedure near call, so it's proc near, the stack is loaded with the instruction pointer, the location of the procedure is now loaded onto the instruction pointer, and life goes on. When it hits the return, it pops it back off the stack. In the case of a far call, the procedure could be located anywhere in memory, not within the 64K memory space. In this case, not only must the instruction pointer be updated, but also the code segment. The code segment has to point to the base of the new memory where the code is residing, where the procedural code is residing. So in this case, you push the current instruction pointer, you push the current code segment, then you load the new code segment and the new instruction pointer onto the processor, execute the procedure, and then when the return instruction is encountered, the old instruction pointer and the old code segment are popped off the stack and life goes on. Let's now talk about macros. So macros are a little different from procedures. So now macros is similar, and it's actually more similar to a function than anything else. It is faster than executing a procedure, and macros can take parameters. Procedures cannot. That's the primary difference between macros and procedures. The two primary differences, one is it can take parameters, and the other one is that a macro will get inserted in the main program as often as you call it. So let's assume that there is a prototype code. It's called the prototype code. Once when you write the macro, that's called the prototype code. At the time of assembly, whenever you call the macro, the prototype code is inserted in your main program by the assembler. Let's assume that the macro is 7 bytes long. And in this example, we have called the macro 3 times. So in this example, actually the macro is 16 bytes long. But if you call it 3 times, the assembler automatically introduces 16 lines of code, that is 16 bytes of code, 3 times in your main program. So the main program expands by that much. And this is your second primary difference. One is you can have parameters to macros. Second one is macros insert what is called inline code. Right? So what are the differences between procedures and macros? Number one, both can be called any number of times in a program. Both allow for easy maintenance. Both the macro, the prototype code of the macro is the only thing that you need to maintain. In the case of the procedure, anyway it's only once. You maintain that piece of code, everything is okay. Whenever you change anything to the procedure or to the macro, you need to reassemble the code for obvious reasons. There is a branched execution in the case of a procedure. So that means main program, branch to procedure, come back to return instruction, come back to the main program. In the case of a macro, it is inline execution because the macro is inserted inline by the assembler for execution of the processor. Macros are typically very small pieces of code. You only need to define them as a macro because you want to call it so many times and because you want to maintain it easily. Macros save time, procedures save memory. So the primary difference again, because macros are inline, procedures are not inline code. Macro call is simply replaced by the original code. The procedure is a jump or a branch instruction. You can pass direct parameters to the macros, but not to a procedure. So both the macro and the procedure are programming constructions. They use the call instruction, C-A-L-L, and there are two different constructs that you can use as a programmer to make your life easier, to reduce the number of errors in your program, and in case there is an error or you want to change, you can do it once and use it many times. I hope this gave you a feel for what a procedure and a macro are. Of course, I would, as always, urge you to read up a little bit more on these. Our next video is really about the interrupt architecture of the 8086. So we're moving back to hardware, where we speak about interrupts and how to use them in the world of the 8086 microprocessor. Till then, happy macros and procedures. Thank you.